Okay, so per y'all's request, I'm going to work out the trig identity from your unit exam. So here was my expression. I had sine plus cosine squared times sine of theta over sine plus cosine to the fourth minus sine plus cosine squared, and I'm trying to verify that that's equal to 1/2 secant theta. If you remember, they're very picky on how these proofs look, and we always want to pick one side, and usually we pick the more complicated side so that we can like dwindle our way down to the less complicated side. So I'm going to start by notating that I'm going to start with the left-hand side. When I look at this, my gut is like, okay, I can square this, but to the fourth, that's pretty nasty. But if I notice, I see that I have this sine plus cosine theta several times. So I can kind of pretend that these are like one thing that I see over and over again. I notice here I have something to the fourth minus something squared. So, for example, if I had a u to the fourth minus a u squared, I can actually factor out like two of those, and I would have u squared times u squared minus 1. So similar thinking, right? I can kind of factor this out if I were to redistribute. Remember, you want to keep the 1 there because if I were to redistribute, I want to actually have the u squared there. If I were to redistribute, I'd have u to the fourth minus u squared. So I can factor out some, but u in this case, I'm just going to use as like sine plus cosine. That's going to make my life a lot easier, and I can maybe cancel this out at the beginning. So what I'm going to do first is just rewrite the denominator. So everything on the numerator will stay the same. But on the bottom, I'm actually going to factor out a sine plus cosine quantity squared. So I have a sine plus cosine theta squared, but I can multiply that by sine theta plus cosine theta squared minus 1. Because if I were to redistribute, I would have sine plus cosine to the fourth minus sine plus cosine squared. So looking here, now that this is being, well, no, let me get my pen. Now that this is being multiplied by this, and these two things are multiplying, that's when I'm allowed to cancel. So notice I can't cancel like these here because I have this minus sign. But now that these are multiplying, now I can cancel that whole sine squared theta. So at this point, I write an equal sign because I'm writing that the next line is equivalent to the one above it. I have sine theta over sine theta plus cosine theta squared minus 1. So at this point, I got to figure out how I can simplify further. Well, I can't cancel out these signs because, again, I'm like adding and squaring. So my little thought is to go ahead and square this sine theta plus cosine theta. The shortcut to that, I'll go ahead and write over here, just on the side. If I have an a plus b squared, then my shortcut's always going to be a squared plus 2ab plus b squared. And all this is the box. So if you want to check using like an a plus b and an a plus b, you'll see how that comes about. If, just for another side note, if I had an a minus b squared, it's actually the same equation, but just a minus 2ab plus b squared, because a negative times a negative is still going to give me that positive b squared. So over here, using this pattern that I know, I can have sine squared theta plus 2. My a and b are sine theta and cosine theta. Then I have cosine squared theta. So that's just the inside. And I still have this minus 1. So I need to make sure I don't forget that minus 1. Well, looking at this equation now, I find that I have a sine squared plus a cosine squared. Be careful, this can only work if it's sine plus cosine. If you had a sine squared minus a cosine squared, that does not equal 1. But I'm going to use that Pythagorean identity. So my sine theta is actually, now I'm going to make this a 1. So I'm crossing that out just to remind myself. Plus the 2 sine theta cosine theta. Then I still have this minus 1. So now looking here, I have a 1 plus 2 sine cosine theta and a minus 1. Well, now those can cancel, so I'll have sine theta over 2 sine theta cosine theta. So what this is saying is I have 2 times sine theta times cosine theta. So now that this is all multiplying, again, I can cancel. So now I have 1 over 2 cosine theta, which, if these are multiplying, I can always simplify by writing 1 over 2 times 1 over cosine. That's a really handy way to split something up by multiplication, because now I know that 1 over cosine theta is secant theta. So I have 1/2 secant theta, which equals my right-hand